Good afternoon. There you go. I think there is energy in the room now. Welcome everyone. Today is the first day. I'm sure a couple of you have heard the general session where even Pat talked about things of network slicing, the next thing that is going to emerge in the technology world. So here we are. The topic for today's session is on 5G readiness, the importance for network slicing and service function chaining. My name is Dharma Rajan and I work as a principal solution architect at VMware in the Telco Network Function Virtualization Business Unit. My background has been on Telecom, working with Cisco, Ericsson, and now at VMware. Joining me as co-presenter is Amit Tiwari from Affirmed Networks. And thanks Amit for joining us at VMworld Barcelona. Amit and I presented this session at VMworld US. We are again representing this session here in Europe. And we are hopeful that this will be of very useful to you. With that, let us get started. This is standard disclaimer. I'm sure by now some of you have started to memorize it. So by the time you leave VMworld, I'm sure each of you may be able to say it out, Okay, these presentations do not have real product, future product, everything. Okay, what is it we are going to talk about today? What is it you're going to get from this session today? You will learn about what is 5G. What is a VMware vCloud NFV platform on which you can deploy 5G solutions? Understand what is network slicing? Why is it important? Why is service function chaining important in a virtualized environment and especially for telcos? And also learn about how Affirmed networks have implemented a network slicing technology that will work for a 4G environment, and as you move to transition to 5G, how these can be made use of. So these are the things you are going to learn as part of this session. So with that, let us quickly go through the agenda. The agenda for today is we talk about 5G evolution, its characteristic, then what is network slicing from a 5G perspective. We'll get to the details about it. What is the role of service function chaining and how network slicing and service function chaining will start to interact as we get into the future. Then network slicing from Affirmed networks. Sounds good? Ready to roll? Okay. Now, as we go through this session, keep your questions and we will try to complete this session about 50 minutes. I'll spend about 30-35 minutes and then Amit will come on stage and talk about Affirmed and then we will take the questions. So for the questions, please raise your hand so that we'll have mics around and then get the mic so that because the entire session is being recorded so that your questions can be recorded as well and it make it easy for others who are going to look at this session on video. With that, let's start with the first thing. What is 5G evolution? What does G stands for? Generation. It's the 5th generation of network. And so we are now at that 5th generation. What happened from generation 1 to generation 5? Did we get lost? No, we did something different, right? So let us first look at that from an infrastructure point of view and then get to what really is 5G. So if you look at the traditional telecom industry, the 1G and the 2G networks came into being in the 1980s and the 90s. Then came the 3G network. That was when mobile telephony really started to pick up and volume usage of wireless technology became more available. And these networks were basically built with infrastructure that was provided by telecom operators, network equipment providers. starting from the ground up, right from the hardware, the operating system, the middleware, the applications were all owned and provided by the network equipment providers. So service providers had to build silos of networks in order to gain. Then as 4G started, the concept of standards and how can I build advanced telecom computing architecture, some of you have heard. That is how open standards for hardware came into being. And as that evolution started, we demanded more and more as consumers, right? We started to say, okay, I want more services, I want more voice. But we said, okay, more data, more bandwidth. But we as consumers also gave the service provider a hard time. We started to say, okay, can I get the telephone call for just 1 cent a minute? Or better yet, can you give it voice for free? That was our motto. So service provider had to go and dig in because for them, their average revenue per user was going on decreasing. So they had to find ways how they can enrich their infrastructure such that they can give those services and bandwidth, but make that infrastructure efficient enough because the utilization in their hardware infrastructure, because they had built on a monolithic platform, was just than 20%. Then came the concept of virtualization, which helped them to increase their utilization and all of that. So as the new generation of 4G networks and 5G networks are being built, more and more of virtualization is what you see. There are several service providers who have started. If I go to 5G, my baseline is going to be on a virtualized infrastructure platform. Okay? With that said, what is 5G and why is 5G important? 5G is the next generation of wireless technology after 4G, long-term evolution, LTE and 3G networks. So what really does 5G promise for us? First, as users, it is a super fast connectivity. It is supposed to be 100 times faster than 4G. And we always want correct information at our fingertips. And this can be achieved with 5G. Because the expectation is it will offer a latency reduction of 4x to 5x reduction compared to 4G networks. In addition, 5G is expected to provide connectivity to a large number of IoT devices, which also means it will support high bandwidth, high spectral efficiency by way of ability to handle these large mobile data volume. Now, what do users on the other hand see? That massive connectivity, high-end spectrum, the very wide coverage. When you have all this wide coverage, what is the need? The radio network. The radio network has to be much more efficient in order to handle this multitude of devices. At the radio network level, they expect the battery life of those radios have to be much improved, that battery life improvement. So these are the things that 5G is planned to deliver. Once, if this is the delivery aspect from a technical point of view, you translate that to what type of applications that can have and what does that give us as consumers. The end result that each of us will see is a sort of a connected community. You now start to have small business that rely on the mobile network, the smart utilities, smart cities, smartphones, connected cars. We talk about all of this, right? So connectivity, you are driving, the signal lights would understand where you are from, what is the potential, all those types of entities. So you are going to go from everything becomes smart agriculture. So the life is changing to a more digital transmission stage. Okay? But as you look into it, and we also said 5G from a technology point of view is going to reduce the latency, improve the bandwidth and all of it. What type of applications that we as consumers can envisage in this type? There are two classes of application you will see here. If you look at the bottom, right from less than 1 megabit per second to 100 megabit per second, and for a latency up to 10 milliseconds, you have a certain group of applications. Now, some of these applications are available even today in a 4G network. But as you go along, you will find that efficiency of those applications. Let me give you an example. Today, if we are in a 4G network and we are downloading a movie, on an average, it takes around 6 minutes to download a complete movie. In a 5G network, the expectation is you can download the same movie in about 30 seconds or less. How cool, right? So our kids will be not downloading movies every few seconds. But on the other hand, you see on the rightmost corner, greater than 10 milliseconds and delay of less than 1 millisecond. Think about connected car devices. Think about a surgeon who is having sensors gloves, doing a remote surgery. Those types of application, augmented reality, where even the slightest deviation in the network causing latency related issue can cause disaster. The FirstNet responder system in the US that AT&T is building across is sort of looking at these types of characteristics where there is high data greater than 1 gigabit per second can be transmitted at a very low latency of 1 millisecond. This is the high end of applications. So these are the applications that will transfer. Then you have things like drone, Internet of Things. Now, so these types of, the network has to have that capability, the resiliency, the high availability, the reliability, all of those characteristic built in, self-healing type characteristic built in order to provide these type of services. Now, let us take a brief look at, are we ready on this? Because the spectrum is a clear important thing here. If you take a 4G network, all your cell phones today are on 4G. You are in a room where there's a lot of windows or anything, you are able to talk seamlessly. The signal goes through. Sometimes you are in a concrete building, okay, you have some challenges. Why is that? That is because of the low-end spectrum. The 4G and the 3G networks were built with those low-end spectrum. As you move to 5G, you have thousands of these devices. So you need to have these antennas at every different points. And these spectrums cannot break into those windows, so they reflect back. Thus, you need to have different types of radios. At the same time, you need to have a high spectrum. That is why you see many countries have started to release spectrums at the higher end. The US is planning to auction out spectrum this month, and as you see these auctions in the 28 gigahertz and 24 gigahertz band starting to happen, you will start to see more and more 5G reality trials happen. So spectrum is an important thing that in this equation. What you see in the middle image is what the type of radio signals will happen. The technology behind this is called massive MIMO. Multiple inputs, multiple outputs. And because of this, smaller radios appearing at very close locations. Why is this related to what we are doing in virtualization? Because the transition that is happening is the baseband units that are there in 4G are transitioning to smaller radios, and these smaller radios get deployed as virtual form factors. They may be deployed as containers which may be instantiated on demand, and when not needed, those containers can be turned off. They may be instantiated as a function, as a service. They may be instantiated as a microservice. So as we go into this, RAN virtualization is extended out, and different virtual BBUs are going to take the form factors that were not prevalent in 4G networks. Thus, the change in the spectrum is transitioning at the infrastructure level to certain units that can be deployed even at electrical lamppost. You could have a small unit with a virtual machine container working inside of it. So with that said, are we ready for that virtual infrastructure with 5G? We are. If you look at it, the 4G network, core virtualization, which we in the industry started about 3 years ago. VMware was the leader. We started out with a telco network function virtualization business unit in VMware 3 years back, and we have proven in production more than 90 plus customers. You saw Pat showing today the numbers. 350 million subscriber and above are using for their everyday telephony call that runs on a VMware virtual infrastructure. So you may be here, if you are using Vodafone, some of your telephony calls are going through a virtual infrastructure, Telefonica like that. Now, what are the solutions? Voice IP multimedia subsystem, evolved packet core, content customer premises equipment. These are the type of solution that is already deployed in 4G in a virtual infrastructure. So the core infrastructure virtualization has happened. The next step that we are seeing is the radio access network virtualization. RAN virtualization is not as easy as a core. When we started out, we provided the concept. If you can virtualize the core of the network, you can virtualize the other segments, that is the access network and the transport network. We have proven that the core of the network can be virtualized. Then when you start to look at the radio access network, you can see here, if you look at a 5G application, the RAN network elements are getting broken down, because one of the key tenets of network function virtualization is how can you separate from the physical entities into multiple virtual network functions so that you can intelligently pass the packet from one entity to the other through the entities of interest. So if you take a RAN network, what you will see is the front hall and the back hall, there is a disaggregation that is happening. There is a control plane entities which are closer to the user, data plane entities which are very close to the center of the core network. This type of disaggregation will start to happen as we get to 5G, so that you can have control of the user. When you think about connected car and all of that, the signaling has to be as efficient, as close to the possible to the user, than how to manage that data, forwarding plane. Okay. So with that happening, which is the platform that can support all of this? As you start to disintegrate, one of the key things here is, how can I build, whether it is a RAN virtualization, whether it is the transport network virtualization, whether it is the core virtualization, whether it is a micro data center, or it is a multi-access edge computing node that I want to build. How can I build this in a common infrastructure and manage it very efficiently? And that is where the VMware vCloud NFV platform comes into being. This is the platform which is made up of a solution. The solution is made up of very specifically to meet telco carrier grade needs. We use our standard VMware products, but which has been used in the enterprise world for mission critical applications. But not only the bottom blue box is what we sell as a vCloud NFV platform. What we do is each of these compute, storage and networking infrastructure layer, we add additional features and functionality that will make it a truly carrier-grade platform for a telco environment. A totally agnostic to any type of hardware you use, whether it is for compute, whether it is for storage, whether it is for networking. You pick your vendor of choice. The basic essence principle of NFV was provide that freedom of choice. We provide you that freedom of choice from a hardware perspective. Similarly, we will provide you that freedom of choice from that virtual network function perspective. You can take an evolved packet core solution, which may have an MME, a P gateway, S gateway. You could mix and match the vendor of your choice because they are built based on telecom standards. Now, you could put any vendor VNF and securely demarcate every VNF to the lowest common denominator of its use, whether it is for compute, whether it is for networking, whether it is for storage or I/O, to the lowest common denominator, so that when a problem occurs, you will know this fault came from this vendor, and you can have security across each VNF. That security is provided through the virtual infrastructure manager, whether it is the vCloud director or it is a VMware integrated OpenStack. Okay? Then operations management, so that you can do your day-to-day operation. Today, we have the IMS, evolved packet core, customer premises equipment, SD-WAN related, as well as content data network, your TV network. All these use cases have been deployed in production. As we see, the same platform can be used for virtual RAN, micro data center, multi-access edge computing, any sort of 5G deployment, IoT, smart cities, smart communities. You have a plethora of use cases, same common platform. It helps you to get that extendability across the different regions. So with that said, now let me switch gears a bit. Why is centralized RAN drives the need for the high data plane? One of the key things is, as you put all these different new technologies, connected car, lot of packet, data plane intensive things, right? You're also looking at high performance. And VMware in this regard has developed a new virtual switch called the NVDS. There was a session at 11 a.m. today. Some of you may have attended this. If not, take a look at that recording. This is a topic by itself. The idea is this. As you get to all this distributed architecture environment, you will see packets right from 64 byte to 1024 bytes or from different IMICs. But we have to provide you this level of near zero packet loss. 1 in a million packet can only be lost. That is the level to which we keep. And with that, you can support very linear scalability. Today with the switch, you can saturate a 10 gig link or a 40 gig link. And there is very low latency that 5G needs can be achieved with no jitter. So these are the things you can look at. And there is a session on this. If you have not looked at that session, please look at the recordings. Okay? So what we are saying here is you now have a platform which is sort of ready for any 5G network deployment. And you can get the data plane performance that is expected for a 5G network. With that said, now I want to switch gears. Now that you know there is a common platform that you can deploy across for any type of virtual network functions, the trend with 5G is, okay, I am a virtual network operator. I don't want to own the hardware. I don't want to own the software. I want to have a slice of a network, a logical slice of a network, and I pay for it, Uber service. Can I get that? Anybody interested in doing that? Okay. So that comes to the topic of network slicing. How can I take a logical network? I put the hardware infrastructure, all of it. I create an entire logical network, compute, storage, networking, operations, and all of it. I have huge. Now I have the volume to span across, where there's a pool of resources abstracted and logically segmented securely. how can I slice that network into different slices? Because traditionally, if you look at the network, they were built of monolithic architecture. Okay, I want to put a solution, I buy a bunch of racks, hardware and all of it, silo. Another silo, my utilization may be just 120%, but I'm investing a lot of capex and opex into it and operations, right? These monolithic networks, how do I transition that as I get to 5G, and how do I slice that network? This is a slice. Everybody has seen pizza slice, right? My favorite slice is the vegetarian slice here. Look at all these slices. What is the base? The base is hardware, right? Common hardware for everything. On top of it, there is a secret sauce. You can think of it as the virtualization layer, less than 150 MB, software. On top of it, you have the VNFs, which are the sort of the puddings in top, right? So you can think of it like, how do I create a common base and create different layers about it? And how can I create a self-contained logical network? The beauty of this is that self-contained logical network has certain assigned quality of service and quality of experience requirement and SLAs that the service provider have to meet, and they can guarantee that. So how can I build an end-to-end self-contained logical network which has well-defined quality of service and quality of experience parameters assigned to it? And how can I put different functionalities or application into that and meet those SLAs? So what are the different type of slices one can envisage? You have the physical network. On top of it, you build an overlay infrastructure that gives you, like, for example, use NSX. You build an overlay network on top of it, and then you start to put. So you have all the components of vSphere, vSAN, and all of it that you saw in the vCloud NFV architecture. Then you start to build different slices. One slice may be exclusively for evolved packet core slice. You can put all the data plane intensive functions there. The other slice may be an IP multimedia subsystem. So an MVNO can come and say, okay, I need these two slices in order to provide a voice over LTE application service for my customers this, and I need it for this period of time. Maybe some may need a slice with a different capacity and quality of service during Christmas time or something when there is more demand. After the demand goes down, they can reduce their need for that slice. So it's a type of service that is available on demand. You could have a third slice that would just say customer premises equipment. It may just have a virtual firewall, virtual load balancer, virtual router, virtual NAT, all the customer premises equipment. So there may be enterprises which may take only that slice, and they can be securely managed. So these are called the horizontal slices. You could have other type of slice, which is the vertical slice based on specific applications or functionality. That could be a slice for smart homes, a slice for autonomous driving, connected cars. So these are the different types of slices that one can envisage. Now, as you look back into the standards, there are different ways of implementation of this. In the 4G networks, you have access point naming, which Amit will talk about. Then you have standards like D-Core, dedicated core, and ED-Core, enhanced dedicated core for signaling. You have 3GPP standards with release 16, which is coming, which is very specifically devoted in the area of network slicing. So standards are also starting to emerge in this area. Now, why is all this important? As we get to 5G, is how reality is going to be network slicing. Does it have a business? So very recently, there was a study that is done by ABI Research, and they estimate that network slicing is going to be a $66 billion industry. Think of this It's a virtual infrastructure base you have. And on top of this, you are building a lot of 5G applications that needs to meet the different latency needs, sensitivity needs, as well as different quality of service. You see different types of MVNOs already, they are there. Many of these MVNOs have already started to work on different types of applications. Then you have very targeted service. Take for example the AT&T first responder system. As soon as get a 911 call, they have to respond within a certain period of time for that region. The first responder emergency system is an application by itself with a very targeted service. You have other enhanced mobile broadband. I need high bandwidth, 10 gigabit per second, augmented reality and those sort of application. Then the other end you have ultra low latency related application, 1 millisecond related application. And the third you have machine type, smart agriculture, smart machine, mining industry. The mining industry is one of them which is asking for a lot of some of these applications, machine. And so what you see here is the big set of applications which is going to transform the digital transformation, and that is why you see that potential opportunity from a business point of view. Okay? Now with that said, okay, is everything good and green, ready to go? Okay, I see nods, yes, I see, okay. Okay, there are certain areas where we have challenges. We cannot say that everything is always good, right? So there are challenges. The Telemanagement Forum, a well-recognized body in telecom, did a very recent study looking at different operators and network providers and started to ask questions. So as you get to 5G and you are talking about all these applications, what type of challenges would we see? Very many from an operations point of view, end-to-end, because it's a complex distributed network. So you need to have the tools in order to manage this. Then the OSS, BSS layer has to be well positioned, so and also from an edge computing. So these are the different areas where their opportunity exists for improvement. As all this come together, we will see the realization of 5G and some of these applications. Now, one of the key things here is, at the very first time, initial we said, we have different virtual network functions. And these virtual network function needs to communicate, and you need to have that ability for that packet to have some intelligence into it. How do you provide that intelligence? That leads us to our next topic of the role of service function chaining with network slicing. I'll quickly go through this. So if you take service function chaining, today you have a physical firewall, you have a router. Think about the functionalities. A physical firewall can provide deep packet inspection, access control, network address translation. A physical router can provide layer 2 switching. When a packet comes in, you have assigned, there's no intelligence to the packet. It has to follow a sequence of functions. Should all these, it's an inline function. Should every packet go through all of these inline functions? Very specifically, think of these network element transitioning out as virtual network function. What happens? As VNF, they get disintegrated into multiple virtual network functions. Because it is all software, you now have the ability to add that intelligence within the packet so that at every packet, at every VNF level, can make an intelligent decision as to what is my next hop, based on the metadata information that is there in the packet. And that ability to do that is what leads to what is service function chaining. You have here 4 VNFs. By default, every packet may have to go through VNF 1 to 2 to 3 to 4. But if there is intelligence built into the packet at VNF 1 level, and that intelligence identifies that that packet doesn't have to go through VNF 2, which may be a load balancer, VNF 3, which may be an IDS, IPS function, VNF 4 may direct it to an application, that intelligence, that service chain changes dynamically. So the ability to change that session and how to do about it is something I had done a session in 2017 VMworld. So if you want to get more details into that, please look at that recording. This goes into very detail on this. With this idea of service function chaining, how does it work with network slicing? So now I have a logical network built, abstracted. I have sliced that network, and within each slice, I can build that intelligence and create a service function chain. Thereby, within each slice now, I have the ability to identify which packet goes through which VNF of interest for that session. I could build slices like this, whether it is a slice for evolved packet core, IMS, or for a customer premises, and then interact with each of these, interact with this slice, the inter-slice communication, along with slice security, slice management, day 2 operation. So service function chaining and network slicing sort of will go hand in hand as the technology evolves. Okay? So these are things to be kept in mind. Now, let us give one more last. You have built your physical network, and how does it work with network slicing? You may have not only virtual network function after you build, you may also have physical network functions. Then you can create a common slice, which is any other slice can use, apply service function chaining within that slice, and when you create, for example, an SD-WAN related slice or UCP slice, it can use some of the entities within the common slice. So you can build a service function chain between the common slice and an SD-WAN slice. That's one. Similarly, you could have a vRAN slice communicating with a common services slice, all the orange lines that you see. A evolved packet core slice is a build. So these are set of horizontal slices you can build, and you can take it right across to an IMS slice or across the WAN into different micros, data center, or the edge. So what you see here is, as the entire architecture spans not only the main data center, but also the edges, you can continue to have that slicing function as well as a service chain. These are all potential possibilities to help enrich the 5G environment. Now that we have talked about all of this, at the very early stage, I did mention about 4G and how Affirmed has implemented certain level of network slicing. So let me invite Amit to come and talk about Affirmed networks. Thanks, Mike.
Thanks, Rajan. Thank you.
Thanks, Rajan. That was a great segue into my part. So if you think of network slicing, as Rajan was talking about, slicing has a whole set of values today, right? It gets implemented today, as you see, the VSSF or the slice selection function that is used to expand the richness of services that are actually available to the consumers of MNOs, MVNOs, and others, i.e., and the way it gets done today, for example, is through, if you think of basically the APNs, the tracking area, which is driven through DNS, co-location or proximity of the S gateway and the P gateway pairing, as well as gateway weighting, right? So think of these are very standard, IP based, basically assign certain criteria to what you could call broad segues into these different categories, which lets you apply network slicing. And this is how, I'm sure you've noticed over the last, several years, how MNOs have actually been able to add services and then manage them without it becoming, an operational overburden, so to say, for their operations teams. So as network slicing gets deployed today, think about it. There's, today on our devices, or even our handsets or our corporate networks, There are different types of requirements for different applications. Some are, and this is all relative. As I get into 5G and kind of what Rajan talked about 5G, you'll see the difference. It's all relatively speaking, but there are requirements for security, encryption, latency, from a diversity of requirements. Cost, there are certain use cases that are very well funded because of the business case that they're tied to. I'll give you an example. When you think of IoT, connected car is a business case that kind of makes sense already, right? It works in something that gets deployed quite a bit. There are a whole set of new use cases that are actually coming into being that MNOs are trying to figure out the business case, on. And out there, being able to actually clearly account for the compute cost associated with that function and that service helps folks determine, hey, this is a service that I can deploy on this network, or I need to optimize, right? And if I optimize, this is the cost associated with this service, and hence I can A, offer it, B, how do I charge for it? So it's a key part that gets addressed today. And then there is differentiated services. So within a service, this is again done by the criteria that I talked about earlier. Those differentiated services can actually be granularized based on those criteria that we just talked about in the last view graph, and then those services be offered. So if you think about it, from a network topology perspective, and kind of building upon what Rajan was talking about, running on VMware, vCloud, and FV, same platform that Rajan described. Think about this. You actually can have this. Let's just take the example of APNs, right? You can have an APN-based network slice where you can actually go out and create a slice for consumer traffic, enterprise traffic, IoT traffic, like I was talking about connected car and others. And then, MVNO slice, right? Each one of them can be tied to an APN or, a few of those handful of criteria that are available today. And each one of those slices can be statically configured. In these slices, you can actually go out and determine all these things we talked about, the requirements of the application, the cost or the optimization of the cost, and how it gets offered, and how you determine the business case for it. It is still very manual. This is how things get deployed, in the first few waves of virtualization. That's how slicing gets deployed. Now, here's the cool part. This is the stuff that Rajan was talking about, and as we get to the next generation of slicing, the key and the coolness factor in slicing that gets us all excited about is the fact that when you start using VSSF, you're no longer doing this as a predetermined fixed network slice that has to be done by hand and then has to be maintained by hand, but actually you can actually start using something like the VSSF. And now think about this. This is almost like if you remember the last view graph in this one, it's a fractal view. You start decomposing those slices, which we call actually sub-slices, within each one of those segments, right? Consumer is not monolithic. There's a million different types of consumers that are out there, right? That, you look at the richness of VMware workloads that they run on vCloud and FV today, for example. Those could actually map to a whole set of different consumers or enterprise or MVNOs or MVNEs, offering MVNOs. Think about this. It's really like a fractal. So when you start getting to the edge of the view graph, each one of those slices can be actually sub-sliced, and that's where the beauty of VSSF comes in, because now you can actually start doing sub-slices based on location, device, loading of the network, time of day, external policy. You can start, talk about granularity, you can get down to customer ID. You can start getting down to realms. Any categorization that actually can be looked at from a machine perspective, you can actually start leveraging this and machine learning to start spawning up automated slices. Now, add to the capabilities of the vCloud and FV platform. Think about this. We can actually do dynamic workload assignment and scaling. So VSSF with dynamic workload assignment, scaling gives you the level of flexibility on automation that in the past was just not available. And Affirmed has launched this on vCloud and FV, and this is something that we feel very strongly will change the landscape in terms of how different services are offered. It will enable MNOs MVNEs, MVNOs to actually offer way more services that today you are used to expecting from, the cloud providers, for example, right? And that is the direction that we are actually moving the journey of the service provider networks towards. So now think about what I just talked about, and now start thinking of it. Each one of these services that you think of, and the richness of these services grows as more and more services are offered by MNOs and MVNOs, and we are already seeing it, right? Think of all the video services, think of all the video conferencing services, think of audio services, think of conferencing, encryption, banking, our handsets, our devices, and even our corporate devices pretty much are our interface to our jobs and our lives, right? So the set of services that you can imagine are offered on those portable mobile devices like our tablets or our phablets. Each one of these services can be scaled and deployed in this granular subslice model and be maintained way more efficiently by the MNOs or MVNOs than they are done in the past. You start thinking of automation and one-touch provisioning for those network slices in the VSSF context, right? And that really shows the power and the efficiency of being able to deploy by keeping a certain set of baseline APNs. So this is a migration journey. So if you think of Affirmed, obviously, Pat talked about, in his session, how VMware has actually grown, their telco landscape and their footprint. If you think of Affirmed, we kind of live in the service provider, networks, right? Today we have about 90 commercial networks deployed worldwide. Think about this. Service provider networks move in a continuum, right? These are very reliable, robust, and global networks that move in a continuum. They don't disconnect and reconnect, right? Not just as in our sessions, but also services. They don't abruptly discontinue a service. We expect certain services from our MNOs. They get better, they get faster. In some cases they get cheaper, right? But it is a continuum. So, the beauty of what we get really excited about is the fact, the baseline of APN-based slicing stays. We actually start adding more sub-slices to those functions, right? As we move, towards VSSF. Basically, the sub-slicing function lets us pick additional resources to go slice upon on top of those, the initial 4 or 5, granularities that we have available in the past. One of the really challenges of, slicing, as much as it organizes services within these kind of, verticals or horizontal slices we talk about, is they touch multiple organizations. When you start creating a function like a VSSF and do slicing in the context of a VSSF, now all those interfaces, even to those cross-organizational boundaries, are taken care of because the VSSF is already doing that, and now you're running services on top of that. So you don't have to go out and start doing cross-organizational alignment when you deploy a service. You already have that when you deploy the VSSF, and now you just run it, right? So think of the VSSF becoming a platform that sits on top of vCloud and FV and lets you do network slicing. It really helps with operations because every SLA that's tied to a service can now be very easily, has a visibility dashboard that you can actually start looking at SLAs, you can start looking at return on investment. It also helps you kind of, utilize the resources that are tied to each one of the gateways that becomes the gateway to that network slice. You can start thinking of these in terms of virtual gateways for network slicing. And one key part, this is the power of VMware Affirmed together, 1 + 1 equals more than 3 in this case, is when you start thinking of dynamic workload placement and scaling and the one-touch provisioning that you start doing with VSSF, it really helps us scale up and down services pretty much on demand, right? It's a far cry from where we started. If you remember what you could call the coarse network slicing today that is widely deployed, and the move that we are now deploying with sub-slicing and VSSF. Now, we talked quite a bit about 5G. So think about this. When you think of the 5G network, all the services that we're talking about, with 5G, there's this inherent expectation of AR-based applications. Think of it, AR-based GPS, right? Think of real-time terrain mapping for self-driving connected cars, right? There's a whole bunch of these new use cases that are only possible in the ultra-low latency 5G realm. those actually require slices that have to be very key for, slicing to be there to actually go deploy those type of services. But then by itself, think of the 5G network as it stands. It is inherently a decomposed and decentralized network. So slices as in horizontal and vertical, the contrast that actually Rajan had painted, it's very clear here. Just to run the horizontal network slices in the 5G decentralized network, operationally, there is enough value to actually start moving to an NSSF. But then also, the richness of the basket of services that gets expected pretty much in the 5G realm is much broader. So the vertical slices that actually have to be done as part of that deployment becomes really key as well. So think about this. I wanted to structure my talk in the context of network slicing as it has been deployed today. Like I said, in our commercial networks, we do network slicing as it stands now in the LTE networks. We move to subslicing and fine-grained slicing with VSSF. As we get into 5G and NSSF, the richness of services and the scale of services and what is absolutely required to manage those services, NSSF becomes pretty much a given, right? Automation with NSSF is a key. And if you summarize all of this together, as we move forward, I won't go into each one of these. I've actually talked to most of them in my talk up till now. This is my last view graph. From an operational maintenance perspective, it's very key because with slices, you can actually be doing things to certain slice and have that traffic be migrated onto another slice that is very identical in terms of compute and characterization of latency and such on that other slice. APN migration, makes it very easy. It's pretty much an automated process that you can do on certain triggers of policy. Sandboxing, service providers obviously have kind of this requirement to be able to run certain services and limit them to geographical areas or a certain enterprise. Makes it very simple to do that on sandboxing, with network slicing. Fine-grained, network slicing has the ability to target applications and to much finer categories than actually what's been available in the past. It lets you actually deploy new types of gateway functions and not have to go impact the rest of the network, limit it to a certain gateway. Another very key area that sometimes gets overlooked is, as we are moving, think about this, VMware, Affirmed together, we are driving this journey, to the hybrid cloud, across, on-prem deployment, private cloud, public cloud, hybrid cloud. We move across all these realms, right? Think about as we're doing all this stuff that's moving the service providers onto the clouds and a mix and hybrid and on-prem, there's still a whole set of networks that are still physical. Let's not forget that part, right? There's a whole large set of networks that are still PNF based. So with slicing, it actually creates a very, very seamless transition from physical to virtual, actually tying up slices that have incremental number of virtual functions, and we move traffic across. It is a much more elegant way than it's possible. I already talked about VNF elasticity, and the ability to drive new services and not impact the entire network, actually fine-grain it down to the smallest possible domain that you can think of, takes away the risk, which service providers have to take into account all the time. So all in all, you can see how network slicing running on top of a platform like vCloud and FV is something that's real, it's today, and as we move in our journey towards 5G and cloudification, is a very essential component of the journey. Thank you. Rajan.
Thanks, Amit. So, in conclusion, what did we learn? I'll quickly summarize, and I have 2 more slides before we go for questions. First, we learned a bit about what is 5G and how it is gaining momentum within the industries and the different use cases. Then we talked about what is a common platform that you can use to deploy 5G services, whether it is for IoT related use cases or any other type of telco related use cases. Why network slicing and service function chaining are important attributes that needs to be considered in a 5G network. I hope all of you got that. And Amit talked about the reality of 5G being used in 4G and how, as you migrate to 5G, some of these concepts can be made use of. With that, I am hopeful that all of you got some information in this session. Two points. Don't forget to fill out the survey. So make sure you fill the survey because it's important. We do read it and we take your feedback. Then there are a couple of other sessions I would recommend. So I'm going to leave this here as we start to answer the questions. So a couple of sessions that are there on SD-WAN, as well as if you want to come and talk to me in person, is the Meet the Expert session. And VMware recently acquired Dell EMC's Service Assurance Suite, and that is folded into the VMware NFE business unit. There's a talk on that tomorrow with Swisscom, so please join that. So with that, the floor is open for questions. Amit, can you join us on stage? Any questions? Please raise your hands. We have people holding mics. If you're not going to ask questions, I'm going to ask Amit to ask the question. Was this clear, not clear session? Anybody, any comments? Very quiet audience.
It's after lunch. We should have had a coffee break in the first session, I guess.
You guys want us to get coffee? Okay.
Looks like we covered it, Dharma.
Okay. Very good. Thanks everyone for coming.
Thank you.